In this video, we're going to do the last two examples of the molecular and empirical formula problems. So let's go ahead and take a look. The answer keys are also found in your slide deck, but try these problems out yourself first, and then afterwards, check your answer in this video. So make sure you pause, try it out, then check your answer. So we have a compound at 75.46 carbon, 4.43% hydrogen, and 20.10% oxygen by mass. Its molecular weight, or molar mass, in other words, is 318.31 grams per mole. What is the molecular formula of this compound? So our first step is finding the empirical formula using all the above steps that we mentioned over here. So we have to do our percent to mass. And that's by assuming 100 grams. And so when you do that, you get C, 75.46 grams. You get H, 4.43 grams. You get O, 20.10 grams. Then we have to go from mass to moles. And we can do that by doing moles is equal to mass over molar mass. So always the same steps here. Divided by, so this is grams, by the way, grams. So divided by 12.01 grams per mole. Divided by 1.01 grams per mole. Divided by 16.00 grams per mole. Cross out grams for each of these, and we're left with moles for each of these. So let's go ahead and plug these into our calculator and see if we get the same answers. So 75.46 divided by 12.01 gives us about 6.283097419 moles. And then this over here gives us 4.43 divided by 1.01, 4.38, 61318, 614 moles. And then lastly, this one over here is 20.10 divided by 16, and we get 1.25625 moles. Now we divide by small, and the smallest one is the moles of O2, so I'll just divide by, of O, so divided by N of O, divided by N of O, divided by N of O. That divided by itself is 1. Next, we'll do 4.386, 138614 divided by 1.25625. We get 3.49153623. And then over here, so sadly we can't round that one. We get 6.283097419 divided by 1.25625. This one is 5.00147, so on and so forth, but we can round this one to 5. So almost all of them are roundable except for that middle one. So we're going to have to multiply until whole. And it looks like this is about 3.5. So if we multiply everything by 2, that should do the trick. So we'll get 5 times 2 is 10. And then this 3.491, so 3.49153623 times 2 is about 6.98 with a few more after, but we can round that in the roundable range right now to 7. And then this is also multiplied by 2, so that's 2. So the empirical formula is C10H7O2. Now we can find the molar mass of the empirical formula of C10H7O2 by simply doing 10 times 12.01 plus 7 times 1.01 plus 2 times 16, and I get 159.17 grams per mole. Now I can find the multiplying factor by doing the molar mass of the molecular over empirical. So it's going to be 318.31 grams per mole divided by the 159.17 grams per mole. Cross those out, and I get 318.31 divided by that number there, 1.9998, which is approximately 2. So now I can multiply the empirical formula from above, the C10H7O2 by 2. Everything gets multiplied by 2 there. And so we get C20H14O4. And that is our empirical formula. We can go double check our answers in the slide deck over here. So C10H7O2 and C20H14O4. I believe that's what we got. C20H14O4. Exactly. So that was an example where we had to find a molecular formula, but we had to find our empirical formula first. And here we have our last example. So I'm not going to redo the empirical formula part because you'll notice that we actually already did this example up here. We found the empirical formula of aspartame in one of the examples previously. So I'm just going to grab it from there, and those are the steps to do that. So it was C14H18N2O5. C14H18N2O5. This is from a previous step above. I'll just write C above for this step. So I'll find the molar mass of that. So molar mass of empirical is going to be 14 times 12.01 plus 18 times 1.01 plus 2 times 14.01 for the nitrogen plus 5 times 16 for the oxygen. And we get a molar mass of 294.34 grams per mole. Now we'll find our multiplying factor by doing the molar mass of the molecular given to us in the question over the molar mass of the empirical, which we found. So it's going to be the molar mass of the molecular is 294.30 grams per mole, and the empirical 294.34 grams per mole. We're a little bit off. It shouldn't be higher, but in this case it is, most likely due to some experimental error. Divide those, we get 294.30 divided by our answer, and we get about 0.999, which is approximately 1. So in other words, we're multiplying our empirical formula by 1. So we're not changing it. That means that our empirical formula and our molecular formula are one and the same. This is our final answer over here because our multiplying factor was 1. And so we can double check our work in our slide deck over here. This was the example with aspartame. And if you take a look at all the work, you get your final formula of C14H18N2O5 for the empirical. And if you want to find the molecular, you do your multiplying factor. You get approximately 1. Multiply everything by 1, and you get the same formula in the end. So your empirical was your molecular formula. And those were the final examples of empirical and molecular formulas done for this lesson. Remember to retry these examples, to frame your questions or your answers in the way these tables help you to organize your answers, and life will be a little bit easier for you when you do these problems. Then you can try the worksheets that are associated with this in the learning goals, and also the exit tickets on Brightspace.